Here we go. All right. Our topic that we're going to discuss next goes under the heading of projectile motion. And the classic thought experiment, well, actually it's not a thought experiment because this actually has been carried out, and we may try and show you this today. The classic example for projectile motion, or at least to discuss the basics of it, goes like this. I have two bullets. One is simply going to be released to fall to the ground, and the other one is going to be shot out of, a gun parallel to the ground. But these are connected or engineered in such a way that at the instant that this bullet exits from the barrel of the gun, the non-shot bullet is released to drop to the ground. And then the question is posed, which one hits the ground first? Okay, how many people know the right answer? What is it?
The bullet that's just close to the ground.
Okay, you would think that this, I think most people, if they have to say choose one or the other, they would think this one, because this only has this length to fall directly to the ground. And this one, it will get pulled to the ground, but it is going to follow a trajectory, so it would hit the ground much further away. Now, barring, well, even if there is a little bit of air resistance, the real answer is they both hit the ground at the same time. Even though this one, people say, didn't it travel a whole lot further? Literally, yes. But this is where the idea of vectors comes into play. And one particular aspect of vectors, I'm just going to write it this way. When two vectors are perpendicular to each other, they are said to be independent of each other. And independent is kind of a fancy term that means what is happening in one dimension does not impact the other dimension. So in this particular example with the two bullets, we are in a two-dimensional situation. Now here's where I think I brought this up before, that we're not going to go beyond 2 dimensions, but we have two different two-dimension scenarios. Most, I think all of the problems yesterday that we did, where we were having objects move around the surface of the Earth, our 2 dimensions was like a piece of paper oriented this way. Everything was moving around on that plane. But in projectile motion, our 2-dimensional plane is no longer horizontal, it is vertical. So things are moving in this plane. And in this plane, we have, our 2 dimensions are the horizontal dimension and the vertical dimension. And we are going to come to find out that we have different things going on, different types of motion behavior in each one of those dimensions. So whenever you are thinking of projectile motion, think vertical dimension, horizontal dimension. Now for this bullet that just gets dropped, what's the only dimension it moves in? The vertical dimension, because it has nothing that's making it move in the horizontal dimension. This bullet, when it gets shot out of the gun, it has horizontal motion. But the thing is that, vertically speaking, this bullet will be doing exactly the same thing that this bullet that got dropped is doing. The only difference is, while it is moving down vertically, identically to this one, it is also moving to the side. So what we are going to try and do is we are going to try and model this thing. So this is where, for the people watching this video, this could get a little crazy, because I'm actually going to video what we're doing so you can see it, but I'm going to need a second person to slow-mo what we're doing so that I can then show it on the TV. So I don't know if this is going to make this video better or worse, because there'll be all this downtime, because I'm not stopping anything. I'm just running this till we're done. Anybody want to be the videographer for us here? Come on. Okay. So when we get there, I'll have you doing this, but I got to get this thing set up first, and I may have to have you like do it at an angle so we could like watch. All right. So for people out there in video land, here we go. Yeah, we might have, this is going to be interesting. All right, so the thing we're going to use is this device right here. Oh, and just to make, oh, I already have a brake here. Awesome. God, I just happen to have crap all over the place here. This thing here is a setup that is going to give us a very bare bones way of trying to simulate our bullet example. And what this consists of is a device, and I think I'm going to need, let's see. Can I hit this? Yeah, I'm going to have to get something a little bit more substantial. Okay, yeah, this will work. It's spring-loaded, and it has this axle or piston, and when it is set, I can put a ball and hang it on this post that sticks out this way, and over here they have a couple holes drilled so it'll hold an identical ball here. Now what's going to happen is this little, I'll call it a handle, kind of is caught in a groove, but with my little piece of plastic, my tapping device, I can tap this. So what will happen is when this is released, what happens is the main shaft here gets shoved this way. Now when that happens, it's going to kick this ball off to project it out that way. And over here, this post will then disappear, and at the moment that the post ends up disappearing into the device, this will just start to drop straight to the ground. And by the time this post projects out, this ball will be on its way outward. Okay? Now the key thing is we have to try and have this project horizontally. So I have a tiny little level here that I am using to try and make sure we are as level as possible, which is not such an easy thing. Okay. So again, people watching the video, pretty boring. Ooh, that's good. Okay. So I think we are set to go here. Oh, now I need one other thing. We may have to like move the video there again. And who thinks they have good eyes?
Sure.
Okay, this is what I need you to do. You're gonna have this blue tape,
Okay.
and you're gonna be kind of over in that direction. You're gonna have to watch the replay, because
Okay.
your job is to watch this ball that gets projected out there and to mark on the ground where it hits
Okay.
as close as possible. So basically, yeah, you're just gonna want to watch over there, and you are only watching this thing. So
Where's
do
it,
not
like,
get.
about gonna land.
I'm gonna say it's over in the area in front of Liam's desk area.
Got it.
Okay, and then let's see. All right, Sarah, you ready? You're gonna slow-mo this, and then we're gonna. And I'm trying to think. I think the best.
It was for the.
All right, so let's see. So what you're gonna need to do, I'm trying to think of the best way. Let's see. Let me have you slide your desk over, because I think what we're gonna do is slide this over as well, so that I think this is gonna work. So that I think you're gonna want to be back here, because I'm gonna mark. See, I like this because people out in video land will be saying, "God, this is boring." It's like, this is real science. This is the way it happens. It's not super. It's not always like super fun. Okay, so you need to be able to see the ground somewhere around here where this piece of blue tape is, and you're going to need to be able to maybe see the ground where my foot is. Does everything fit?
Yeah.
Okay. Okay, so everybody watching on the video is just like listening to me talk.
Nervous.
Okay, are you ready?
Yeah.
All right, go ahead and hit start. Are we going?
Yep.
All right, here we go. Okay, excellent. All right, so just so that we take some quick measurements here, I'm getting a meter stick. All right, we got that? Because this is the part where I go, you saw they hit the ground at the same time, right? And most people are like, what? So we're not gonna do that again. But what I am going to do is they both fell, so to speak, the same length. Vertically, let's see, I'm gonna say this is about 76 centimeters and up to 45. Let's like just over 1.2 meters. Okay. Now they both fell vertically the same distance because they both ended up hitting the ground. But this one, there's one, and there is about 1.55. But the ball that got projected out horizontally went 1.55 meters. So if we were to just, this is where we're getting crazy again for people on the video. For the actual numbers, and I'm not being exact, I'm just kind of eyeballing. What do we say this was? About 1.2 meters. And this one that hit the ground went about 1.55 meters. So if we just went ahead and pretended this was a triangle and we did our Pythagorean step, and we'll go ahead and do this, 1.2 squared plus 1.55 squared, and then we square root that answer, we get almost 2 meters. So this ball that got projected traveled, even in a straight line, if we imagined it was doing that, it traveled almost twice as far. But now we're going to have to look at the video and see, do we corroborate this idea that, but they both hit the ground at the same time? And I wasn't even watching that close, so I don't know. So let's see, got to get this worked out. I need my Apple TV. This is high risk. All right. Let's see if this works now. Come on. There we go. All right. Let me see. I'm going to move you guys around here. Oh, God. No, not you. Just move my... It's like I'm showing a video. I'm letting the TV take over. So let's see.
You should look at Google.
Oh, God. You guys ever, like, end up, like, seeing yourself and go, oh, that's painful. All right.
Doing it right now.
Look at Reese. Reese is, like, focused over there on the left. He's ready to roll.
I was nervous.
Okay, here we go.
Good dog.
Oh, yeah. Left the volume on, so like,
I was so
It's so slow. This is bad.
It'll happen. Hang in there. Try to tap.
Oh.
Okay, now hold on. See where they are? Right here, right here. This one's already projected out, and we don't have the best angle, you know, because we're kind of angling down so we can see the floor. But these both right now above the ground are still the same height above the ground. Even though this one has ejected probably almost maybe half a meter. All right? Hopefully this doesn't go like super fast. Okay, now this guy's, I don't think it's hit quite yet. It's just about to, and that guy is also just about ready to hit the ground. Okay, so even though we'll bring it back. All right, so as we go here,
This is proof.
well, let's see, I'm going to bring it back. Okay, not exact, but for having traveled twice as far, that one over there was hitting the ground almost at the same time as this one. And back up here, am I sure that this thing is even perfectly level? You know, my level said it was, but this might be not engineered perfectly level either. So when this is where I will have some people go, it didn't hit exactly at the same time. It's like, do you realize one of them went twice as far and it still stayed in the air just about the same amount of time? So the idea of projecting something at least perfectly horizontal to the ground, it doesn't give you any more air time, but it gives you the illusion of more air time because you do travel further. And that's because of that idea of independence in vectors. Because what's making both of them fall to the ground?
Gravity.
Gravity. Does gravity pull onto anything differently, you know, if it's just moving perfectly level? No, it pulls it down equally as this one that just falls straight down. All right? So, very good videography.
Thank you.
All right? Now we're going to come back here. You know what this reminds me of? This is like Modern Family when Phil decides to be like a robot or something like that, and he puts himself on an iPad so you only see his face. Okay. Oh, damn it. No. I got to show you one more. Oh, I can't. Oh, God damn it. I can't show you this one because, although, did I keep it on my phone? Some people might. I'm still recording, right? They're getting all this. Oh, I still got it. This is gonna be great. Yeah. I don't know if this. I'm gonna show you another thing. How much time do we have left?
Like 5 minutes.
Okay. I'm going to show you another thing here. This thing is called a ballistics cart. And the idea behind the ballistics cart, and I think I'm going to have to actually bring this over here. Might have to follow up on this tomorrow, just so you can see how this thing works. What? What happened?
We're in it.
Oh.
Oh, yeah, you guys are in this. All right.
Hello.
All right. This is. There's the ground. Who's got white shoes? Okay. This is a ballistics cart. And the idea behind the ballistics cart, for those of you over there, if you want to, you can stand up and watch this. This is spring loaded, and we have this big ball bearing here. And you can push this down, and it like sets the spring. And then there is a release. And then they have this very clever magnetic release. There's an old school version of this that really sucked. So when you pull this little magnet away, it releases a little lever that falls down, and then it releases the spring mechanism, and this is what you get. Okay? All right? So again, when we do this, and we go, hey, it's not moving. Wow, fell right back into the hole. Shocker. Okay? Now, because we have time for this, we really go with 5, right? Not 4?
It's 46.
46. Oh, yeah, we got plenty of time. Now we're going to do something slightly different. And I have this videoed. I spent, I think it was an hour after school yesterday trying to get this videoed all by myself. We are bringing out one of our little toy cars.
Is it dump truck?
This is the Chevy. And this is what's wrong with the Chevy? Now, this isn't gonna like move super fast, but what did we learn about the motion of all the toy cars in that lab?
They're constant.
Constant. So let's see, we're all pushed down. So this will be we'll maybe duplicate this at the beginning. Yeah, we're gonna just have to let this roll. So we're gonna push this guy now.
Yay.
Hey, guess what's gonna happen?
It's like walking around.
Here we go.
Oh!
It still fell right back into the damn thing. How does that work? Okay? Now the key thing is that this guy was moving at a constant velocity. And so tomorrow we will break this one down. I wish I had one that would push this a little bit faster, because you'd still get the same effect that this ball pops up and it falls back down into the cup, even though it's now moving. Okay,
Views on this video.
Yeah, this is a good one.
we're gonna see.